right, we're going to start the review for the video answer key. I'm going to start with the first objective, which is just working with the basic exponential and logarithmic properties. So the first couple problems I am expanding, so what I need to remember is that multiplication turns into addition and that division turns into subtraction. Um, so what I'm actually going to do, though, instead of looking at this as a division problem, I'm going to look at this as all multiplication. So ignoring the log, I'm just going to focus on x times x plus 4 times x to the negative 7th. And I'm going to rewrite that as x times. And now what's going to happen is my multiplication is going to turn into addition. And now when I expand it into 3 logs for each of the 3 terms that I now have up there, I'm going to put the log in front of each one. So log 7x plus log 7 of x plus 4, keep that in parentheses. And then the negative 7 as an exponent will move in front as multiplication. Number 1's been expanded. Number 2, same idea. What I'm going to do is rewrite it as multiplication. So 3 times x to the negative 1 times y cubed. I'm going to turn all of that multiplication into addition. And then each of those 3 terms is going to get its own log. So log 4 of 3 plus, and then that negative 1 exponent will go as multiplication, negative 1 log 4 of x, and then the 3 will also go in front as multiplication. I'm going to have to squish that in there. Okay, and that's number 2. All right, and number 3, I am condensing. So the first thing I'm going to do is I'm just going to temporarily ignore the logs because it's too much to look at. And I'm going to rewrite it as all addition. So I'm going to add the opposite on the minus 3. And now I'm just going to take all the multiplication, the 1/2, the 3, or I'm sorry, the negative 3 and the 4, and put it back as an exponent. So that will become 16 to the 1/2 plus x to the negative 3 plus y to the 4th. And then since I'm working backwards and condensing, the addition turns into multiplication. And then from there, I'm just going to follow the rules of exponents. So 16 to the 1/2, that's the same as 4. My x to the negative 3 will move into the denominator due to the negative exponent, and my y to the 4th will stay on top. And now I'm just going to put the log that I ignored back with it. And a good idea, and I'm not sure if I did this on all of the printable answer key, is I'm just going to put this in parentheses to show that all of that is to the log with a base of 5. Okay? All right, let's go and take a look at number 4. So here I am expanding. So what I'm going to do here is I'm going to, first of all, realize that this 5 square root of x is and over the square root of y. And then moving below the blank, I'm going to rewrite it as exponents. And I'm going to rewrite the y to the 1/2 in the numerator. So I'm going to put a negative exponent with it. And then all of that multiplication, again, is going to turn into addition. And now I'm going to bring the log back, and as I bring the log back to each of the 3 terms, I'm going to be putting the exponents in front as multiplication. So the first one will just be log 5 of 5 plus 1/2 with log 5 of x plus negative 1/2, whoops, log 5 of y. Now, if you remember, if the base of the log and the number behind it are the same as is what's happening here in that first term, that's actually worth 1. So if you see that, it would be better to turn that into 1, and then this would actually be the best answer to have. Would I be looking for that on the test? It would be good to see. I mean, we did talk about that. If you miss it, we'll all survive. So this is the best answer for number 4. Okay? All right, let's scroll up to number 5. Express it as a single log. That means I want to condense it. So again, I'm going to temporarily ignore my logs. And the fact that they have addition says I'm going to turn it into multiplication. So just taking 11 times 50, I get 550. And I'm just going to put that 550 back with 1 log. And there's my answer. Number 6, I'm going to expand. So again, I'm going to rewrite it out to see what everything is multiplied. So for number 6, that's the same as ignoring the log. 4 times x times y to the fourth, and I'm moving the z up into a numerator, so z to the negative fifth. And now each of those multiplication signs will become additions, and now each of the 4 terms will get their own log with it. So going through that one, I'm going to go ahead and try to write it in the blank. I'm going to have log a of 4 plus log a of x. And then going back to these exponents of the 4 and the negative 5, they're just going to move in as multiplication. So 4 log a of y plus negative 5 log a, this is going to squish in there, of z. Okay? And that is number 6. All right, 7, going back to the condensing. So again, just so there's less to focus on, I'm going to ignore the logs. And when I rewrite it, I'm going to take all the things that are multiplied to the logs, the 7, the 2, and the 3, and move them back as exponents. So it's 2 to the 7th plus x to the 5th plus y cubed. And now all of this addition will turn into multiplication. And just cleaning it up, 2 to the 7th power is 128. And then I'll just bring along the x to the 5th y cubed, and I will put the 1 log of base 4 in front of it. So there's 7 for you. Number 8, condensing down. Again, I'd rather work with just all addition. So first I'm going to add the opposite, so plus negative 2. Next, I'm just going to ignore the logs. And when I rewrite this without the logs, I'm going to take, again, anything that's multiplied to the logs, the 1/5, the negative 2, the 1/2, and put it back as an exponent. So 32 to the 1/5 plus x to the negative 2 plus y to the 1/2. And now all of that addition turns into multiplication. And I'm just going to clean it up. 32 to the 1/5, it's like the 5th root of 32, so that's 2. The negative of x squared puts the x on the bottom. And the y to the 1/2, I'll just write it as the square root, or you could write it as y to the 1/2. And now that log that I ignored, I'm just going to bring back. And here is my final answer for 8. So there's the front page. All right, let's go to the back. On the next page, you will be working with the different formulas. On the test, you will be given all the formulas, so don't worry about that. But for the review, you have to know what formula to use. So when I read the first problem, which I'm going to assume that you will take the time to read, they do mention compound continuously, which means I'm going to use that PERT formula. And when I use the PERT formula, I'm going to use the E button on my calculator to do the math primarily. But substituting everything in, I have P is 2300. E is, again, that number that I'm actually going to put in there. My rate is 9% as a decimal, but the question is, for how long will it take me to reach a balance of 4150? Well, if I look here, I'm actually asked to solve for t. And we know how to solve for t. We know how to solve for exponents that are unknown. What I'm going to do is loop it into a log. Before I can loop it into a log, I've got to do a little bit of cleanup. So the first thing I'm going to have to do is divide by the 2300. So I'm going to move this problem down a little bit. So when I divide by 2300, on the left side, I'm left with just the e. And on the right side, just rounding 1.804. And now I'm ready to loop it. So kind of going this way. It's going to be log e of 1.804, and that's going to equal this 0.09t. All right, so I cleaned it up a little bit. Now, when I go for the calculator to start solving for this, log e, I'm just going to rewrite it as ln. And then I can go straight to the buttons on the calculator and type in ln with that decimal number. And when I do that, ln of the 1.804 is 0.59, and that equals the 0.09t. And then when I divide, I get, as a rounded decimal, about 6.56 years. So there's my final answer there. So remember, if you're asked to solve for something, sometimes it's not straight putting into the calculator. You might have to loop it And in this case, we had to loop it into a log. All right, number 10a, they mentioned compound annually. So this is the regular compound interest formula, and annually means that my n is going to be 1, which will be pretty simple to type in. So I'm going to take my initial amount, 370, and then in parentheses, 1 plus my rate over how often it's compounded, which I realize I don't need the 1, but I want you guys to see, if that annually were daily or weekly, then that 1 would be a different number. So essentially, I can just type this straight in my calculator because my fraction is just worth 0.04, and my exponent is just worth 5. So as far as the calculator goes, if I want to type this in, I could just type this in. And when I do type that in, I get $450.16. So there's 10A. 10B, when I read about this problem, this is all about decay. So I'm going to use the decay formula because the price of a car goes down. So again, it's the initial amount, which is 12,500, 1 minus the rate, which is 15%, um, and it's only after 1 year. So when I type this into my calculator, I get $10,625 as the value of my car. So in 1 year, you've lost about $2,000 value on your car. All right, on 11, 12, 13, 14, I'm finding the inverse. The main thing about the inverses is that you switch x and y around, and then you take y where it is, and you work to get it by itself. So we will be looping to go from a log to an exponent or an exponent to a log, but remember, you cannot loop until it's just the log. So when I look at number 11, the 3x plus 2, that's all part of the log, so I won't have to worry there. But the first thing I'm going to do is switch x and y, so f of x, which is y, becomes x, and in my parentheses goes 3y plus 2, and now I'm ready to loop. When I loop, I need a base of the log, and when there's not a number there, it's an understood 10, so I'm going to go ahead and loop, and looping around, it goes 10 to the x power equals the 3y plus 2. And now what I'm going to do to get the y by itself, the first thing I'm going to move is subtract 2, and next I'm going to divide by 3. Now, when I divide by 3, and you look at my answer, look at the answer in the blank. I'm going to put this in red. And that 10 over x divided by 3 really means that what I have is 1/3 times 10 to the x, because it's only the x that gets the 10. And if I put the 3 under the 10 like this, you might think that it's 10/3 to the x power. So it's 1/3 times 10 to the x minus, and then it's actually 2/3. And on the written answer key, I have 2. It should be 2/3. Okay? And then I'm done. There's my inverse. All right, let's go to number 12. Same idea. I'm going to switch x and y, and I'm going to put log e for the sake of looping. And here when I'm ready to loop, I'm not quite ready to loop yet. I need to move the 7, and I need to move this minus 3 because they are not part of the log. So the first thing I'm going to move is I'm going to add 3, and then I'm going to divide by 7. And at this point, I have just the log. So now I'm ready to loop. So it's going to be e to this big exponent over y. There's number 12. And I think I'm going to end the video for this part. So pick the second part. We'll start with question 13.